You're listening to Electrician Live with your host, Paul Abernathy. Well, hello, everybody. Welcome to another episode of Electrician Live, where we talk about all things electrically related. On today's show, we're going to talk a little bit about bonding and Article 250. And I love Article 250. It is probably one of the more complicated articles for people to understand, but it's also one of those ones that's most gratifying. Once you understand it, you learn it, you get it, and you keep the basic concepts in mind of what you're trying to do when you're in 250, then it makes it a little easier as you move forward and things get more complicated, more things you look at and you go, God, is that bonded right? Is that grounded right? Is everything done right? And once you start getting it, again, it just all of a sudden it's like a little light comes on and you're like, oh, wait a minute. I understand what's going on now. It's like, but the process takes a little bit. And again, I get a lot of questions about grounding and bonding. So for today's lesson, we're going to talk grounding and bonding with an emphasis today on bonding. So Article 250 is actually made up of 10 parts. And the part that we're going to be focusing on today, at least for today's topic, which is service bonding, is going to be part 5, and that is entitled bonding. And so we're going to cover 250.90, 250.92, 250.94, and we're going to be talking about 250.96 and 250.97. And that's going to be the scope of what we talk about in today's episode. And we'll try to move through this as quick as possible, hopefully being able to convey the message to you in a clear, concise manner. That's our focus. All right. So first things first, let's talk bonding. The concept of bonding is tying metal parts together, tying non-current carrying metal parts together. So one, they're at the same potential. They're acting as one. Everything's connected together. But when you go back and look at the definition of Article 100, which again is where the definitions are going to be if they're going to be used in more than one article, and you go read the definition and you look at it and you go, well, this makes sense. Why do we bond things together? But what does bonding mean, and what happens when we do the practice of bonding things together? It becomes bonded. So we have a definition of bonded, which means the act of doing it and the way the code prescribes it is we're bonding all the things together. We're essentially tying these non-current carrying metal parts together. And when we're done, they're all going to be bonded together. So you've got a present tense and a past tense, I guess, the way you would look at it. So bonding is the act. The result is everything is bonded. So what is the definition? Bonded, or the act of bonding, the physical act, is connecting to establish electrical continuity and conductivity. So if I have one metal plate and I have another metal plate and I connect them together with a wire, they are bonded together. The act of me putting a 250.8 listed lug on one plate and in putting that same lug on another plate and running a wire between this plate to that plate, the act of me doing it is bonding. When it's completed, it is all bonded. Okay, makes sense? So that's how you look at the definitions and understand how that process takes place. That then brings us to part 5, which is bonding. And we're going to start this journey where logically you would start when you come to a premise or a building, is we're going to start at the service. And that's where we're going to start. But we need to look and kind of see what is being covered in part 5. What is our principal focus? And that's where we look at 250.90. What did I say 9 for? 250.90. All right. And if it's kind of like, for lack of a better term, the scope of what part 5 is all about. And so it's the general. And let's read it. It says, and I should tell you, I am in the 2020 edition of the National Electrical Code, for those that are following along, and I don't believe there's any changes significant in what we're going to talk about today, anything really significant between the 17 to the 20 to worry about. Now, 250.90 general says bonding shall be provided where necessary to ensure electrical continuity and the capacity to conduct safely any fault current likely to be imposed. So what's important in that statement, which is very subtle, is that it's so important for you to use proper fittings. It's important for you to use proper termination techniques, and all of these items that are allowed for terminations would be in 250.8. And you're following all that. You're doing everything like you're supposed to do. You're sizing bonding jumpers properly, doing everything that you need to do to ensure that when it's necessary for these components to carry fault current, that they're going to be able to carry it, and it's going to have the continuity and the capacity to carry that fault current when necessary to clear an overcurrent protected device and remove the hazard. We are assuming that you do all that. Now, we're also assuming here that when you're dealing with services, that we're making sure that all of the parts on the supply side, raceways with service conductors coming in, all of that is at the same potential. All of that is connected together as well, giving it the best opportunity for potentially anything on the supply side up to the utilities point to be able to potentially clear it in a fault condition. We hope. We don't control that. That's outside of our scope, but we're tying everything together, getting rid of differences of potential at this location and giving it the best opportunity to do that. Okay. Also, we want to be able to at least make sure that all these connections allow it to get back to the grounded conductor, which goes back to the source, so that, again, in a fault condition, current's never trying to get to the earth. It's in a fault condition, creating current. Everything's trying to get back to the source. So we're making sure that all these connections are all together at the same potential, and we're just following what the code is telling us to create a minimally safe installation. All right, so that's the premise. That's what we're at. That's what we're focusing on. That takes us to 250.92, and that is services. So we're now kicking into the service requirement. Now, there's an A and a B to 250.92. A is going to give me the equipment and what needs to be bonded, and then B is going to give me the method to achieve that bond. Okay? So A says the normally non-current carrying metal parts of equipment indicated in 250.92A1 and A2 shall be bonded together. So this is all electrical equipment that is normally would be non-current carrying. Of course, it carries current under a fault condition, but not under normal conditions. All have to be tied together. And you have a 1 and a 2 here. I'll read each one. Number 1 says all raceways, cable trays, cable bus framework, auxiliary gutters, or service cable armor or sheathing that enclose, contain, or support service conductors except as permitted in 250.80. So 250.80 has an exception when you might be running non-metallic raceways underground, but you're going to use metal elbows, and as long as those elbows are down with a minimum cover of at least 18 inches, then you don't need to connect to that. Then that's fine. It's considered out of touch, if you will. So kind of why it has to give that reference. And then you have item 2, which says all enclosures containing service conductors, including meter fittings, boxes, or the like, interposed in the service raceway or armor. So again, if you're going from a weatherhead down into a meter, that meter is actually interposed into the raceway or cable assembly, whatever it is. It's interposed in the middle of it, basically placing it in the middle of a run. Okay, so it's saying, by the way, those also are going to need bonding requirements. Okay, so that's kind of what we're dealing with when it comes to the service. All of those things have to be bonded. We get it. Now that takes us to how do we do this bonding? And what is the practice? And that is 250.92B. And it says, okay, methods of bonding at the service. So here's how you can do it. We already know what you have to bond. Now we're going to tell you how to do it. It says, bonding jumpers meeting this requirement of this article shall be used around impaired connections, such as reducing washers or oversized concentric or eccentric knockouts, period. So if you're encountering reducing washers or oversized concentric or eccentric knockouts, what you're going to be dealing with is a requirement for bonding jumpers. Point blank. Now, a question that people get asked at this point, we'll obviously cover it later, is what if I don't have reducing washers or oversized concentric or eccentric knockouts? What if I don't encounter those? Maybe I cut my own holes, or maybe I removed all of the rings for concentric or eccentric because that's the size I needed for my fitting. If that's the case, you don't need a bonding jumper. You have other methods that you're going to see here in a second that you still need to bond, ensure the bond. The point is, the next sentence is the one that you have to really remember. Okay? Because if you don't encounter concentric or eccentrics, okay, if you don't encounter those, then there's no bonding jumper necessary. However, it goes on to say, standard lock nuts or bushings shall not be the only means for the bonding required by this section, but shall be permitted to be installed to make a mechanical connection of raceways. So mechanically, you can use standard lock nuts, but to meet the bonding requirement, that is not going to be something you can do. That doesn't matter whether or not there's eccentric or concentric or not. It's in any case, when you're dealing with the service side, you cannot use standard lock nuts to make that bonding connection, period. Now, they can be there for mechanical reasons. Like maybe you use it to hold the fitting on, but then you're going to put on a bonding bushing on top of that, and you get a bonding jumper because you're dealing with concentric or eccentric knockouts. So if I had all of them, it was a punched hole, or I removed all of the eccentric or concentric fillers, and I have just a hole that looks like I punched it, if I'm not using reducing washers, and I'm using the proper size fitting that goes in it, because that's the type of raceway I'm bringing it to it, then it is perfectly fine to do that without a bonding jumper. But you still can't use standard lock nuts. You have other options you're going to have to follow, and we'll read all those in a minute. And one of those examples might be a bonding wedge or a bonding type lock nut, which is different than a standard lock nut. You do have options when you encounter that situation where you have punched holes, or again, there's no concentric or eccentrics. So we know what the rules are when we have those. Those are called impairments, and we have to have bonding jumpers for that. Anything else, we have some other options, and we'll read those in a minute. But again, to hammer home, standard lock nuts are not to be utilized for that bonding component. Mechanically, fine. Bonding, no. Now, you're going to see that that's not the same when you're dealing with branch circuits and feeders, but when it comes to services, it's very much a statement that has to be utilized. Now, let's go on and read the rest of B, and it says, electric continuity at service equipment, service raceways, and service conductor enclosures shall be ensured by one of the following methods. Okay, well, there's 4 here. Now, number 1 is reminding us, it says, bonding equipment to the grounded service conductor in a manner provided in 250.8. Now, 250.8 gives us a list of different things like pressure connectors and different ways to make the connections, to physically make the connections. But B1 is actually allowing me to make the connection of those enclosures over to the actual grounded conductor and meet that requirement. Now, where else you might see that in your journey is in 250.142. In 250.142, it tells us the use of the grounded circuit conductor for grounding equipment on the supply side. So there's an A and a B for load and an A for supply side. Okay. Now, just remember, the load side one is not going to be permitted except for some exceptions that are found in 250.32. But that's a very rare situation. So most of the time, we're simply talking about using the grounded conductor for the supply side connection and that would be utilizing 250.142. Now, the connections itself, the terminals, the lugging, and how you do all that, that is going to be in conformance with 250.8 because that gives you a method of what's permitted to make that connection. Okay, so that's all it's reminding you here, that it is okay. I can bond all of this to the grounded conductor utilizing methods that are in 250.8, and we get additional permission, which doesn't list here, but you get additional permission to do this in 250.142 in case you want to pause this and go look at that. All right, so that's what B1 is dealing with. Now, B2 is saying, okay, any connections utilizing threaded couplings or listed threaded hubs on enclosures if made up wrench tight. So this is what's going to allow me for the couplings for rigid and intermediate, for example. Let's say I'm going from a meter and I'm going through a hub, and then the top of the hub screws in the rigid metal, and it's going up to an overhead mast, and I have two sticks or joints or pieces, whatever you want to call it, of your raceway, in this case, rigid metal conduit, that have to connect together using a coupling. Well, the coupling is suffice to connect each one of the raceways together. Okay, that's just all it's really saying. And it kind of makes it up. And they're all considered fine. Now, as it comes down to the top of the meter enclosure, and it comes into a hub in the top that is threaded, and it's actually usually has 4 bolts on it that go into the top of the meter enclosure, then that is okay because that hub is identified for that application. It has been evaluated as part of that overall piece of equipment and assembly. Another aspect of this would be that you do make things like Myers hubs. And a Myers hubs is basically a fitting, but the majority of them, and you need to check with the manufacturer, it just takes a second to make sure that it's been evaluated for use for grounding and bonding and that application. So once that has been done, then it's perfectly fine. And most of them are, but you just need to check it. Make sure. Okay? So that's kind of giving you the allowance to use something that we probably took for granted anyway, but that's what we've done. And then B3 says, what about threadless couplings and connectors if made up tight for metal raceways and metal clad cables? So this is allowing us to do things like EMT threadless couplings. They usually are set screw. There's other type of couplings that are threadless, but they would be compression, and they're going to be okay. And usually if there's a question about it, then just simply check the listing for that product for use in its application. But again, this is opening up the door for that, and it's perfectly fine. Also, again, for metal clad cable, the connectors are perfectly fine. Again, maybe you're using this is for services, so maybe you're using outside a PVC jacketed MC, and it's outside, so you're using a fitting that's listed for that application outside, condition of use. And that fitting would be evaluated for use with that MC cable. And obviously, MC cable is listed in 230.42 as a wiring method that is okay for service conductors. So again, kind of putting all these pieces together, you see that that's perfectly fine. And then, of course, you've got item number 4. And item number 4 is the one that I usually have to explain a little bit to folks. Not that it's complicated, but just kind of in the context of going back to the general rule in B. And that is, it says, item B4 says, other listed devices such as bonding type lock nuts, bonding bushings, and bushings with bonding jumpers. Okay, so I could have let's go back to the body of the statement here in 250.92B for a second. What if I have concentric or eccentric knockouts, and we know that they're impaired. We know we have to have a bonding jumper. Well, we could utilize B4, and we could use a bushing with bonding jumpers, and that would suffice. Now, what if we had a concentric or eccentrics that are all completely removed, and there's no reducing washer? It's just perfectly sized for the raceway that we're bringing into it. Perfectly fine. And let's just say it's an EMT, and it's coming in to the top, and it's coming into a proper fitting that's going to maintain the integrity of the enclosure. Everything is okay. And it comes into it. Now, it's coming through an opening with no eccentrics. They all been knocked out, but it's perfectly sized. It's what they needed. And that's the case, then I could use a bonding lock nut because I'm not encountering any eccentric rings at this point. It's almost like I punched a hole. So I have other options here. Maybe I want to use a bonding wedge, which is pretty much basically a C-shaped device that slides over the conductors. I like to say it's an oops ring. You made a mistake and you've already pulled the conductors and put a fitting, and now you need to put something on there to do this, and you slide this over because you realize that standard lock nuts cannot work at any point. So you end up putting this in. And usually they have the ability to actually have a screw that drives into the actual fitting, or they actually has the ability to put a lug on there if you happen to need a bonding jumper. So you do have bonding wedges. What I probably see the most is people will shift to where it's a totally punched hole or it has no impairments. They will use a bonding lock nut, which is different than a standard lock nut. Okay. So, I mean, you have different options. Just the takeaway from this is where people get confused is you're required to have a bonding jumper if there's some type of impairment. Okay. If there is no impairment, then you have other options and you don't need the bonding jumper. Now, can you do a bonding jumper if you want? Absolutely. Are you required? Absolutely not, unless you're dealing with an impairment. Okay. The next one that we're going to look at is 250.94, and that is dealing with communication systems. And what we have is an A and a B. Now, prior to 2017, we had just an A, and that was only dealing with intersystem bonding, and that was communication systems. Well, we introduced in 2017 a B, which is basically introduced a bus bar configuration, a 1/4 inch wide, or thick, I should say, 1/4 inch thick, and at least 2 inches wide. And of course, the length of it has to be at least to give you 3 terminals, because that's the requirement for the communications you'll see in a second. But it's got to be long enough in order to be able to also facilitate any other connections that might be made to it. Okay, but at least has to have 3 connections because of the communication requirement. But what we're probably familiar with is, for the years, we had what's called an IBT, which is an intersystem bonding termination. And it's basically just a little bus system. It's a little bus bar in there. Basically looks same as the lugs that would be in your panel, basically what it looks like. And there's a number of them on there. And that would be located at your service or your meter location. It's got to be readily accessible. Well, I don't even know if it has to be readily accessible. I think it just has to be accessible. Let's see. Well, we'll see. We'll see if it has to be readily. I don't think it has to be readily accessible. I think it's just accessible. I don't know. We'll look. We'll see. So anyway, it's right there. And yeah, I'm sure it's not readily. You get to that, and that's where you would make the connections for your communication system requirements. And you have a lot of these requirements, whether it's a DirecTV, whether it's a CATV system, communication system, whatever it might be, they need to make their connections. And for years, we made this connection directly to the grounding electroconductor if it was there, and just simply clamped onto it. But now they're required, if you're going to have communication systems at a building, you're going to have the actual, at least a minimum of 3 terminals there. So let's read this, because you have 2 options, because the first one we're talking about, A, only applies to communication systems, and B is any type of system could go there, like PV, CSST, anything could bond at that point. Okay, make that connection. So again, the difference. So 250.94A deals with intersystem bonding termination devices, and that's all it's going to deal with is for communication. It says an intersystem bonding termination, IBT, for connecting intersystem bonding conductors shall be provided externally to enclosures at the service equipment or metering equipment enclosure and at the disconnection means for additional buildings or structures. Okay, so that's like a detached structure or an additional building that's being fed from the general premise to another building. Okay, now there's exceptions to all this, but we'll get to that at the end. Okay, and it says if the IBT is used, and the reason it says that because, again, the exception is going to say if your building does not have communication systems and you don't need this, so that's why it's got to say it like that. So it's if it's used, it shall comply with the following. And there's 6 items it has to comply with. Number 1, it says be accessible for connection and inspection. Okay, so not readily accessible, just plain accessible. Okay, makes sense. Number 2, consists of a set of terminals with the capacity for connecting not less than 3 intersystem bonding conductors. Okay, so I've got to have at least 3 terminations there for these intersystem bonding conductors that might be necessary based on the system I'm using, whether it's again, dish network, CATV, or whatever. I have to have these terminations, and I have to have at least 3. Okay. Next, it says, and this is A3, it says, it can't interfere, it says not interfere with the opening of the enclosure for the service building, or structure, disconnection means, or metering equipment. So they make some of these that actually mount on the disconnect or on the meter enclosure, and it can't inhibit the operation. That's all it's saying. But they do make some that do mount on it. And it'll have its certain amount of lugs on it as well, but it kind of clamps onto it itself. Number 4 says, at the service equipment, be securely mounted and electrically connected to an enclosure for the service equipment, to the meter enclosure, or to the exposed non-flexible metal service raceway, or be mounted at one of these enclosures and be connected to the enclosure or to the grounding electroconductor with a minimum 6 AWG copper conductor. So this is permitting it to actually be connected to the equipment there. They make those that are designed for that. Or it's giving you the option to be able to connect it. Maybe it's a separate piece of equipment, which many of the ones, I think ILSCO makes one that is separate. And it actually connects over to the grounding electroconductor. So basically, you either connect it to the grounding electroconductor, because that's permitted. There's some that are designed to be in line with it. Or you split bolt onto it and then jump over and then take it through this device, and it kind of just connects to it. And it has to be at least 6 gauge, okay, minimum 6. And that's what we typically would see, that type of application. Now, you got 5, which is basically saying the same thing, but the other one was for service. Now we're talking about the disconnection means at the separate building. It says at the disconnection means for a building or structure, be securely mounted and electrically connected to the metallic enclosure for the building or structure, disconnection means, or be mounted at the disconnection means and be connected to the metallic enclosure or to the grounding electroconductor with a minimum of 6. So same concept, service, same concept for a detached structure or additional building or whatever. This is what you would do. And you give those termination requirements there. So at least 3 terminations, okay? And then it goes, the last one says, the terminals shall be listed as grounding and bonding equipment. Okay, again, they're going to follow the rules of 250.8, but all terminations have to be listed for grounding and bonding. Okay, so that's your general rules that follows the general requirements. Now, there is an exception for an existing building, and this is existing buildings which may already have a grounding electroconductors that are required by something in section 100 of their specific article, like 770, 800, 810, 820, 830. Again, that's dealing with CATV, communications. That's dealing with premise-powered or network-powered broadband. If there's some type of requirement for them to have their own grounding electrodes in their grounding electroconductors or their connection to the existing premise grounding electrode, if that's already in place and you're in an existing building, nothing's going to require me to now put this inter-system bonding. With the caveat that other systems could be applied, the exception does also say it shall be acceptable to have accessible means external to enclosures that could be utilized for this application if necessary. If I have exposed non-flexible metal raceways, if I have an exposed grounding electroconductor, if I have approved means for an external connection to copper or other corrosion-resistant bonding or grounding electroconductor to the grounded raceway or equipment, then that's going to be a location where I can make these connections. But it's not going to require me to do this on an existing building that might already have some other inter-system bonding system in place, or if the existing building also has these accessible means, that I'm going to have at least a location that I could make this connection if I bring some other system to the building. So in new systems, we follow all the rules we just talked about, but there is an allowance for an existing building in some applications that might be present, or if there's also an accessible means that's there that's external and it meets one of the options here, then again, that's going to be fine for you to be able to make that connection if necessary for any system that you might be adding to this existing building. Okay. In other words, it's not going to make you update this to the existing building. All right. So that's the general rules for that application for A. Now let's kick it into B. And the B is one that was introduced in 2017. This is called other means. Now, basically, this is exactly the same way. In a sense, though, now we're using a bar. And if you've seen them, it's a kind of a bus bar. Basically, if you think about this, let's say it's a 1/4 inch by 2 inch wide copper plate, and then they punch holes in it so that you can bring all these connections to this common location. We see this in computer rooms and data rooms all the time. When you're bonding all the equipment together, they'll have this common bus bar that they'll bond everything to. Same scenario. So you can have this installed if you don't want to use the IBT, because in the IBT, you can't take things like PV2 or CSST or whatever. You can't make those connections to it. But in this case, this is a different bar. And this one's fine for you to bring not only the communication, but all of the other connections that you might want to bring to it as well. This can be done here. And so you're given this option. And as long as the bar is at least a 1/4 inch thick and 2 inches wide, now the length of it has to be sufficient to, one, handle at least the minimum of 3 terminations for the communications. But obviously, it's going to have more for the other. And you just have to make sure it has sufficient length to be able to accommodate those other connections. Okay? But it has to have at least 3. And this bus bar shall be securely fastened and installed in an accessible location. Okay? So again, not readily accessible, just an accessible location. Connections shall be made by listed connectors. And of course, listed connectors and things, crimps, and all this stuff is, again, following the rules in 250.8 is extremely important. It also goes on to say, if the aluminum bus bar is used, the installation shall comply with 250.64a. And that's a reminder that you do have external connections outside, can't be within 18 inches of the earth. That's kind of its homage to that requirement, which we have had some slight changes in the 2022. The 2020 edition of the NEC, we've had some changes to 250.64a, so go check those out. But exteriorly, that is still the same. The connection can't be within 18 inches of the earth. Okay? Now, here's the big one, the exception. There's an exception to both of these, A and B. And this exception is, means for connecting intersystem bonding conductors are not required where communication systems are not likely to be used. So most all buildings that you're going to occupy, residences and commercial buildings, you're going to have communication systems there. This rule is going to apply. But what if I have a detached structure that I'm taking and putting a remote distribution panel in, let's say my house, and I'm putting it over there, and I'm not going to have any communication in that building at all? Then I don't need it there. I only need it at my main building. So that's all it's saying. So if you don't have communication, now this is not to be confused with a building. Let's say I build a nice new building, and at the time of the inspection and everything's in, I don't have communication systems in. Look, you're going to have communication systems, whether it's cable, TV, or something at this building. Network, internet, whatever. You're going to have it. So you're going to have to meet this requirement. It's a simple requirement. But you might have a detached garage or accessory building that is not going to have communication of any kind at it. Then it wouldn't be necessary to do it. And that's what the exception is basically telling you. The next is 250.96, which is bonding other enclosures. Now, we're talking about other than service now. So we're talking feeders, branch circuit applications. And there's an A and a B here. Now, the B is dealing with an isolated grounding circuit. A is dealing with in general. And it says, metal raceways, cable trays, cable armor, cable sheeting, enclosures, frames, fittings, and other metal non-current carrying parts that are to serve as equipment grounding conductors. And again, you're tying it all together. With or without the use of supplementary equipment grounding conductors, and that would be an example of, let's say an EMT is being used as an equipment grounding conductor by pulling an insulated equipment ground or bear inside of that raceway. That is actually a supplementary, because the raceway itself is the actual, can be utilized as the equipment grounding conductor. So just kind of making that statement. It says, shall be bonded where necessary to ensure electrical continuity and the capacity to conduct safely any fault current likely to be imposed on them. Again, just like what it stated in the very beginning of part 5 that we talked about. It goes on to say that any non-conductive paint, enamel, or similar coating shall be removed at threads, contact points, and contact surfaces, or shall be connected by means of fittings designed so as to make such removal unnecessary. So this is a difference. Sometimes we have, for example, the easiest way to convey it is we have lock nuts. Some of the lock nuts aren't designed, they're flat, they don't cut into the material, and then you have some that have a slight curve on the end of each segment, and as you tighten it down, it literally cuts into the enclosure and cuts the enamel. Those are making contact. Ones that don't make contact on enamel or whatnot, you're risking it's not making a good contact. So things to think about when you're utilizing different types, things like lock nuts and what you're using on painted surfaces or enamels, things that are baked on enamel. Are you making an adequate connection? Things to think about. Now, the next one is B for isolated grounded parts. Now, I'll just paraphrase this for you. This is where you have some equipment that they're worried about electromagnetic interference or noise or EMF or anything that can cause a problem with that equipment. You can run, obviously, a raceway to this, say metal raceway, to this piece of equipment, and or you could run, I guess, non-metallic or whatever you can run to, and you have an equipment grounding conductor that typically would bond all of the equipment to the grounding system. Okay. But now it needs to be isolated. So what this is allowing you to be able to do is, let's say if you're running I guess it's more important. Let's go on and read it before we get too deep into it, because I think it kind of self-explanatory, but I want to read it. It says isolated grounding circuits. This is for you that actually deal with these type of circuits. It says were installed for the reduction of electromagnetic interference on the grounding circuit. An equipment enclosure supplied by a branch circuit shall be permitted to be isolated from a raceway containing circuits supplying only that equipment by one or more listed non-metallic raceway fittings. So I'm separating the raceway from the actual enclosure, okay, by use of a non-metallic raceway fitting located at the point of attachment of the raceway to the equipment enclosure. So I'm creating a separation from, let's say, a metal raceway, EMT, or whatnot, as I'm running from point A to point B, and I don't want that metal raceway, which is the equipment grounding conductor, let's say, for an EMT, to make the connection to the equipment. So I use a spacer, which is a non-metallic fitting, raceway fitting. Okay, so it's spacer. Gotcha. It says, the metal raceway shall comply with this article and shall be supplemented by an internal insulated equipment grounding conductor installed in accordance with 250-146D to ground the equipment enclosure. Okay, so you have your raceway, which probably qualifies as an equipment grounding conductor, but it's not making connection to the enclosure. So you still need to bond that enclosure. So you use the allowances of the isolated ground follow the rules in 250.146D, make that connection, and you actually are making the connection over to the piece of equipment, and you're going to get the bond to the equipment. That's not going to be a problem. Now, there is an informational note that is important to state, is that use of an isolated equipment grounding conductor does not relieve the requirement for grounding the raceway system. Okay, so again, typically in an EMT, it's going to be connected at one end to the enclosure, follow all the rules that you need to follow. And again, all of the fittings and everything, terminated properly, torqued properly, installed properly, everything done right, then the raceway itself is going to be okay. Okay? That's going to be taken care of. And it's just reminding you of that. But you have that isolated ground that's coming in, and that's what's going to make the connection to the actual piece of equipment's enclosure. And that makes that required connection. Okay? Next in, the one we're going to end on is 250.97, which is bonding for over 250 volt systems. So if I've got a situation and I have circuits that are going to have conductors that are again, you're working in 250 volts to ground or over 250 volts to ground, here's what it says. It says the electrical continuity of metal raceways and cables with metal sheathing that contain any conductor other than service, we're not talking service already has its own rules, shall be insured by one or more of the methods specified for services in 250.92B, except for B1. Remember, B1 was the connection to the grounded conductor. We obviously don't want to do that on feeders or in branch circuit applications. We obviously don't want to do that. That would violate 250.24, A5, I believe. So we don't want to violate that. So you skip the B1, okay, which was that permitted allowance to use the grounded conductor. And again, it's also afforded us in 251.42 to be able to do that on the supply side. We're not talking about that here. We're on the load side. So when we're dealing with that, it reminds us that we still follow the same rules in 250.92B for these over 250 volts. And that means if we encounter concentric or eccentrics, we're going to need bonding jumpers. Same rules. So to make it easy to understand, in your mind, just treat it the same way that you would do for service and just ignore B1. Okay? So you have other options. Now, you do have an exception. And the exception to this rule says, what if you're not encountering oversized concentric or eccentric knockouts? You're not encountering them. Or what if the box you're working with has knockouts that are concentric or eccentric, but the box itself has been already evaluated for use with over 250 volt applications. And of course, if the box is evaluated for that, then the knockouts on it obviously were evaluated as well. And if that's the case, you utilize this exception. And this exception is basically saying, okay, you can use any of these methods here, which to be honest with you, are going to be pretty much any of the fittings that are listed for use with that product anyway. Okay? The only one that's kind of a little different is item 2, and that's talking about where you might bring a rigid or intermediate to a box, and you use a lock nut on the outside and a lock nut on the inside. And again, for this application, that's perfectly fine. Again, if the box is evaluated for over 250 volts, then you can utilize it. You're fine. Okay. So, and if you're not dealing with concentric or eccentric or oversized, then you're perfectly okay to use, again, rigid, intermediate, the 2 lock nut method, one on the outside, one on the inside. Perfectly fine. But then it also goes on to allow you to use fittings with shoulders, which is probably typically what you're going to get with your fittings, that seat firmly against the box. For EMT, flexible metal, that's FMC, and other cable connectors as well. And they have a lock nut on the inside, and that's a standard lock nut. And you're okay for that. And then lastly, item 4 just tells you other listed fittings that are probably listed for the wiring method you're using anyway. Again, perfectly fine. But these would be listed fittings for use with these products. Okay. Now, with that said, most of the fittings, and I worked for NEMA, if you're using a MC, for example, it's going to have a fitting that's listed to be utilized with that MC. And so if the voltage typically on those would be 600 volt rated cables. So obviously it's going to be okay for use in over 250 volts. So any fitting that would be listed for it is going to be fine for that application. So again, this pretty much covers the scope 1, 2, 3, and 4 of all normal applications that we would run into with the dealing with an over 250 volt, all the fittings that are listed for the cable and everything. The key takeaway here is the same as it was for services. If you're dealing with concentric or eccentrics, then you're going to need bonding jumpers. Okay? That's a given because it makes a reference back to 250.92b, and that's where it makes that statement. It's also important to tell you, again, because it makes that statement, it's also reminding you that if you're dealing with the concentrics, eccentrics, or impairments of any way, that you still can't use standard lock nuts, right? That's part of the general rule in 250.92b. But if you're dealing with a situation that you don't encounter those impairments, then you're okay. It tells you right here basically what you can do, and it tells you, again, says standard, it just says lock nuts, nothing special. Okay, so make sure you really identify what you're dealing with, and hopefully I made that pretty clear, that when you can use standard lock nuts and when you can't. And for the most part, services, you can never use a standard lock nut, okay, for that type of assured bonding at all. In over 250 volts for feeder or branch circuit applications, you can use standard lock nuts, okay, as long as you're not encountered oversized concentric or eccentrics. In that scenario, you're going to need bonding jumpers. And because it makes reference to 250.92b, which prohibits the use of standard lock nuts, you need to think about your installation. Now, if the boxes are rated for over 250 volts or you have perfectly cut out holes or punched holes, if that's the case, there you go. You get to utilize the exception, and then standard lock nuts are perfectly fine with use with your fittings for that type of raceway method. Then you're perfectly okay. So that's kind of an overview summary of all of those. So hopefully you got something out of the day's lesson. Again, it's kind of answering some questions that people had sent me. So hopefully that cleared it up for you. If you have any questions, as always, I do my best to try to be as clear as possible. But again, if I confuse you at any point, please give us the opportunity to set the record straight for you and help paint a picture for you that's easier for you to understand. You can always visit our website at masterthenec.com or electrocodecademy.com. Be sure to listen to our podcasts over on electricianlive.com, or you can listen to our regular websites as well, or you can go over to our YouTube channel and watch some of the videos that we do at youtube.com/masterthenec. Be sure to like and subscribe so that you can get a notification of any new videos or any new podcasts that get published on those platforms. Remember, you can also listen to all of our podcasts on all types of platforms like Spreaker and Spotify and Apple Podcast and Google Podcast and iHeartRadio and all these other good platforms that you can listen to at your leisure. So again, thank you for taking the time to spend it with us today. Hopefully you got something out of this. Until next time, folks, stay safe and God bless. You've been listening to Electrician Live with your host, Paul